For example number 4, we want to determine for what values of p is the integral convergent. If you notice that p is the exponent in the denominator. So the integral has a lower limit of 1, an upper limit of infinity of 1 over xp dx. Now what we know from example 1 is that if p was equal to 1, then we got the integral would be divergent. So let's assume that p does not equal 1. So here we have our integral, and then we're going to use our exponent rule. So now we're also going to use our rule where t is going to approach infinity. So we're going to have 1 to t, x to negative p dx. Now, when we take the antiderivative of that, it becomes x to the negative p plus 1 over negative p plus 1 with a lower limit of 1 and an upper limit of 2. So now if we apply that upper and lower limit, we end up getting a limit as t approaches infinity of 1 over 1 minus p times 1 over t to the p minus 1 minus 1. Now, if we say that p is greater than 1, and if we subtract 1 to both sides, then we can say that p minus 1 is greater than 0. So as t approaches infinity, then t to the p minus 1 also approaches infinity. And therefore, 1 over infinity is going to give you 0. So, the integral from 1 to infinity of 1 over x to the p dx is equal to 1 over p minus 1, provided that p is greater than 1. And so the integral converges. But if p is less than 1, then p minus 1 is less than 0. And so therefore 1 over t to the p minus 1, which is equal to 1 to the t, which is equal to t to the 1 minus p, approaches infinity as t approaches infinity, and the integral diverges. So if p is greater than 1, in this particular rule here, when it's 1 over x to the p, we know the integral is going to converge. If it's less than 1, then we know that the integral is going to diverge. So we summarize the result of this example for future reference. So we can say that the integral from 1 to infinity of 1 over x to the p dx is convergent if p is greater than 1, and divergent if p is less than or equal to 1.